in the Negev here in Israel. And Naftali tells me just to call you TP, but maybe you can help me a little bit with your name.
Hi, good afternoon to everyone. Okay, I am Parthasarathi from Ben-Gurion University. I am doing my postdoctoral research. This is part of my work. So this is the topic of my presentation: imaging and analysis of continuous root phenotyping using automated Minirhizotron systems. So study the root system is really necessary to understand the root system processes. So existing methods, root observation methods such as soil coring, excavation and trenching are time consuming. Also it is are time consuming, also laborious, and the minimal invasive root monitoring is a challenging task in undisturbed soil. So the Minirhizotron system offers the view to see the root development in situ the soil, and also the Minirhizotron system allows repeated observations within the rhizosphere. So most of the Minirhizotrons widely used are BART system, which is manually operated, and the manually operated system measurements are severely affected by the more laborious and also long interval temporal measurements. So it is necessary to develop a completely automated AMR system for study the root system for a continuous monitoring. So automatic image capturing system would allow increased sampling frequency. Also, this would allow precise measurements, also continuous root phenotyping of the root system. So objectives of the studies were to develop new automated AMR system and to compare the automated AMR system, in short AMR system, and manual AMR system, comparing the two systems, and to continuously monitor the root system by using the automated AMR system for understanding of the root system development and root zone processes. In this picture, the right side is the well-known BART system, and the next adjacent one is the automated AMR system. This is the camera part. It will move up and down by using the motor, and it is controlled by a mini computer on the top. So this is a comparison of two systems. The left side is the automated AMR system. This captures the picture automatically, and this is the part of the camera which will move up and down and capture the image. So the orange picture is the image captured by the automated AMR system, and the right side one is the BART's AMR system, which is manually operated, and the red pictures captured by the BART's AMR system. The red bars indicate the actual picture taken by the manual AMR system. So when comparing with the two image systems, the AMR system, which have a good quality with 22 pixels per millimeter. In the case of MMR system, it is 18 pixels. Also compared with the size of the picture, the AMR system, which is bigger and wider, 3 times bigger than the MMR system. So with this comparison, I am not going to talk about the technical spec of the camera. We will further move about the precision and continuous phenotyping of the AMR system. So AMR system used to measure the precise monitoring of the root system response, because roots are really sensitive to environmental conditions. So here the AMR system and MMR system both are compared compare the roots. So grafted tomatoes were experimented in the Ramat Negev experimental station. So for validation of the AMR system, the BART system operated to take the images. The measurements such as root length, root diameter, and root counts were extracted from the taken pictures, and it's analyzed and the data were extracted. And root distribution was measured at depth wise. So the length distribution and count distribution of each depth were taken from the total depth. Here, these are the three grafted plants. The Lurca is the scion, and the Arnold is the rootstock. So the Lurca grafted on Arnold. Okay. Lurca grafted on Arnold, and Lurca grafted on Resistor, and Lurca grafted on Lurca. So all the three 3 grafted tomatoes were irrigated with 2 irrigation water qualities. So non-saline and saline irrigation with the electrical conductivity of 1 decisimon and 5 decisimon. So all the treatments were captured with the 2 cameras, 2 AMR systems. The A represents the AMR system and M represents the MMR system. These are captured images from the total root profile from 0 to 70 centimeter of all the genotypes. In the further slides, I will talk about the performance of the AMR systems with the salinity. So this is the root picture represents the root distribution on length basis, on count basis plotted on against each other, and the blue triangles represents the points measured by the AMR system, and green represents the points measured by the MMR system, and the linear regression of black line represents the AMR system and the red line represents the MMR system. Here both the systems showed a similar trend in terms of root distribution. Also both the system corresponded well with each other. Also the slope, when you compare the slope of the two systems, both the slope values are almost 1. So both the systems captured the similar root distribution. This is about the root length. To study the salinity response by using the camera, the relative root length was calculated here by using the root length of grafted plants over its self-grafted. How the changes measured by both the cameras. So the relative root length captured by the MMR system plotted on x-axis, and relative root length measured by the AMR system on y-axis for the two salinities. Here the black line is the linear regression of non-saline irrigation, and red line the linear regression of saline irrigation. In the case of both the salinities, this followed the similar trend. Also, the correspondence is almost similar in both the salinities. When in the case of specific to saline irrigation, the slope is almost 1. So both the cameras measure the similar salinity response by using both the cameras. So in this case, instead of relative root length, the actual root length plotted against each other measured by using the MMR and AMR system. Here the salinity response observed is similar in all the depths except the top layer. So most of the studies previously reported where the top layer will not corresponded well with the other methods, but here the MR system have better correspondence with each other in the top layer. Also the slope is much higher in the top layer. The slope is more than 1 than the rest. This is because of the more root length observed in the top layer by using the AMR system. This is because of the bigger picture, and this is because of the bigger picture, even though the data were normalized to unit centimeter square. And this is about the relative root length, root count, and root diameter. Here the relative value is calculated by using to its salinity to non-salinity, which is given on the y-axis 5 to 1. And here both the cameras were no significant difference in each parameter. Also the median is almost 1 in both the cameras, both the MR systems. Here, but the MMR system, which is unevenly distributed, and the values are much lower. The lower boundary is much lower than the AMR system. Also, the extrapolation points are much higher. This is because of the small image will not exactly measure the relative root changes to salinity. Also the AMR system, it's evenly distributed. Also the both the parameters, it's compact, and the extrapolation also in a exact range. So the AMR system will measure the relative changes to salinity exactly, also precisely. And next we'll see about the continuous monitoring of root system by using AMR camera. This is for better understanding of the root system development and root zone processes. So the next is the video which is captured by the AMR camera at single window, and this will capture the images every 5 minutes, and every 5 minutes for 10 days. And these images were squeezed and made the video by using time-lapse images. So the video is for you. So here the white parts are drying, then again it's wetting, it will be clear. So now it is wetting, then again it's get dry, then again it will produce roots. So this is about the continuous root monitoring in terms of in the video. Here the continuous root monitoring test done in the net house. So here the MMR system used to capture the roots at 2 intervals, day 1 and 8. So here this is a useful practice of BAS MR system. Usually they will go for a weekly interval to measure, or maybe 15 days. But in between the middle 2nd and 7th day, we will miss the information. So we tested the AMR system in the day 2 and day 7. The collected images were analyzed and the root length is exhibited here. In the increasing trend, there is a little variation on day 2 and day 3, but we could not find what is the reason. So then the total root length converted into depth wise. So the first picture, the same total root length plotted depth wise, and the next, so here also we did not see any changes. So then the change in root length was calculated on the second picture. From each day interval, the change in root length plotted. Here we see the difference. The red and green line are the day 2 and day 3 intervals. There is no change in root growth. Then we check the management practices. Here there is a first picking of fruits was done. So this first fruit picking made a little stress to the plant. It affected the root growth on the 2nd and 3rd day, which is clearly seen on the particular depth of 20 to 30 and 30 to 40 centimeter. Here on the 2nd day, the root growth change decreased, and no growth observed on 3rd day, and it completely recovered on subsequent days. So this is the importance of continuous root phenotyping, not only for this but for other stress related root changes. So this is the multiple criteria evaluation for both the AMR and MMR system. The criteria were based on accuracy, effectiveness, and adaptability. So in terms of accuracy, the image quality and size are really important to quantify the root growth by using the root images, because it will the images are used to analyze and get the root data. And image, in terms of image size, the AMR system have a better picture quality, also the bigger size, which will give more root information. In the case of effectiveness, the AMR system take 5 minutes to cover 1 meter tube, and also the MMR system, it takes 10 minutes. In the terms of cost effectiveness, approximately 20 units of AMR system could be installed in the field instead of the MMR system. And in the field condition, in terms of adaptability, it is easy and automated. The AMR system is easy and automated, and in the case of MMR system, it is operated by manually, and also in terms of continuous phenotyping, it is impossible to take daily measurements by using the manual MR system. Also in terms of accessories, the AMR system needs internet connection to send the image to the computer, but in the case of manual MR system, it needs battery and personal computer to see the roots and monitor the roots. So with this study, we found the automated system, MR system, explored the continuous root growth dynamics, and it is efficient and precise and highly repeatable analysis by using continuous monitoring. And it is useful to study the fine root growth because of the bigger image size. We can identify the fine roots and also the root classifications. And it is easier to interpret the root system response to various environmental stresses. So this AMR system can monitor the root system automatically in real time. This low-cost automated AMR system is an excellent solution for continuous non-destructive root phenotyping. Also, this server one this produces large amount of root data for daily basis. Also, you can operate even hourly basis. It produces a lot of data. So this large data needs high throughput automated analysis. To summarize, the automated MR system provides the missing informations of MMR system at field level. So the continuous root phenotyping is precise and effortless even at field level by using this low cost automated MR system. So with this, I thank all those who helped in this research, and for the committee thank you for the committee.